You're right, Mark. For starters, we'd probably do it in Python. I've actually been thinking about redoing sign-up list in Python. All right, so it is 5:30. We have 45 minutes or so, and we have about 47 minutes worth of presentation. So we're going to go ahead and get started and make sure that we have time for Eric to get in the presentation. And of course, we can stick around for a few minutes after to answer questions should you have them. Otherwise, feel free to chat in the chat, and we will answer as we go. So with that, I'll turn it over to Eric.
Good morning or afternoon. Welcome to this talk on migrating a Blackboard building block or B2 to an LTI and REST application. We're coming to you recorded from Madison, Wisconsin in the USA. Today we're going to talk about a little B2 refresher. The previous talk covered B2s and why you might want to migrate them to a different framework, specifically LTI and REST. In this talk, we're going to cover exactly how to do that. So we'll look at an existing B2 for a before and after look. We'll talk about LTI Advantage, which is the most recent version of the IMS Global Learning Tools Interoperability specifications. We'll look at Blackboard's public REST API and how to use that. We'll look at the Ultra Extension Framework briefly, which allows you to extend the Ultra UI to customize that for your application. And we'll look at registration and deployment of your application. Forward-looking statement, I think everything I'm going to talk about today already exists and is in production. I've been with Blackboard for 14 years, and I'm a member of both the IMS Global LTI and Caliper technical working groups. So a little review on what is a B2. Most of you should know what a B2 is if you were coming to a class on how to migrate a B2. But a B2 is a Blackboard building block. It could have been named a B4. It's a Java web application. It has access to Learn's Java APIs, and it has direct access to the Learn database, which could be problematic if you unintentionally did something bad. It runs inside the Learn Java virtual machine, which could also be bad if, say, you ran out of memory or took too many resources inside that virtual machine. Ostensibly, you can use your UI of choice, but most people are going to use some kind of Java server page framework. But you could theoretically use React or Angular for your UI for your building block. It's just a lot more complicated. You do have access to UI hooks within the Learn original experience. You have to configure some fancy XML files. And B2s are not supported in Ultra, and there is no future for them to be supported in Ultra. So with all of the above, there be dragons in B2s. But we're providing us an example B2 that we'll use for this lecture on how to migrate a B2 to an LTI and REST application. And so, for instance, this is the JSP page for the UI for that B2. And rather, we've just coded some of the Java right inside the JSP here. And here we're using the Java API to get the current user and the current course. And then once we've deployed the B2, you can access it from the tools menu and it displays this page. So this is your page, your tool, your UI. It does whatever you want it to do. Here's an example of the BB manifest file you have to set up. You have to give it a name and a description and a handle and the vendor information and define the application and where it's going to be available, where the links are. And then down below here, you have to define some permissions that it needs to be granted. by the Learn system administrator. And then over here we have a standard Java web app, web.xml file that basically defines your web application and defines where you're mapping your servlet to. But enough about B2s, because we don't want to write B2s anymore. We want to take a B2 such as this one and migrate it to a new framework. And that new framework is a combination of standards-based LTI and our public REST API. So what is LTI? It's a UI flow to connect an LMS or VLE, what we call platform in the specs, to an application, or what we call a tool in the specs. It provides single sign-on capabilities, not in the same way that SAML does, but the user is logged into the platform, and when they launch the tool via the UI, there is context information sent about the user, the course, the resource, etc. And so in that sense, the tool can decide to trust that launch if it knows who that user is. So there's a trust relationship that has been agreed upon between the platform and the tool. There are services to get data into and from a platform. So we can get data content such as videos, assignments, or books, or into the platform from the tool, or we can get the roster information and the grade information into the tool, as well as put grades back to the platform. And the key point about LTI is that it's standards-based, and so ostensibly it works with any LMS or VLE, where your building block would have no chance of that. And note there are two versions of LTI that are really in the field today. There's the older LTI 1.1, predated by LTI 1.0, and we'll look at a brief history of LTI. But that's been deprecated, and it's time to build all of your LTI tools with the version 1.3/Advantage, and we'll talk about what those Advantage extensions and capabilities are. So again, what we're talking about is two web applications, which is really what you had with the B2. But in this case, these two web applications don't live in the same process. They live most likely on two different computers across the internet. So you have the learning management system, or the VLE, and we have the application or content provider. A brief history of LTI. Maybe 2010 or so, plus or minus, LTI 1.0 came out, and it supported a resource-linked launch. It was a launch for a particular resource. Probably the first example was a chapter in a book for a publisher. And that was great in 2010, but the internet has evolved in the last 11 years. Then LTI 1.1 came out, and really all it added was the ability to post grades back to the LMS. But it did it in a very simplistic way. It basically allowed you to post a single number from 0 to 1 for a content item, for that resource that was launched to your application. But that wasn't enough. Then, I don't know, 5 or 6 or 7 years ago, they started on LTI 2.0. And it really did the same thing as LTI 1.1, but it solved a bunch of other problems that maybe people weren't necessarily looking for. It solved ways to register the tools. It's added this consumer profile service of what services the tool consumer provided, tool consumer being the LMS or platform in this case. It provided a proxy registration service so that the tool and the platform could talk back to each other, and then similarly it provided a tool setting service. All of that is great stuff, but it didn't really address the underlying issues around LTI, which was that the security model was archaic and obsolete. And so OAuth 1.0 basic security for signing launches had been deprecated and was no longer supported by library vendors. It's not that it was necessarily insecure, but it did rely on a shared key and secret model, which is inherently insecure when you're sharing secrets over email or post-it note. So then about 3 years ago, we got together and we realized we really needed to change the security model around LTI. So we basically scrapped LTI 2. And we came up with a new version of LTI that the marketing geniuses at IMS decided to label LTI 1.3. And the reason they did that was because they wanted to make it look like we really weren't making any functional changes to LTI 1.1. We were just changing the underlying security model. And that's sort of almost true. So rather than an OAuth 1.0 basic launch request, we are using OpenID Connect based messages and signing them with asymmetric keys and passing JWTs. And then for the tool to get data back into the platform or from the platform, it's going to use OAuth2 based service definitions. So this brings the security model to the modern age, which is all great. It does mean, though, that a tool would have to change their code. So that's one thing. And the other thing is that the entire data model has changed because it has to change. With LTI 1.1, it's a bunch of form parameters. With LTI 1.3, it's a single form parameter called an ID token, which is a base 64 encoded JSON web token. And we will look at some of that in more detail. So let's look at the security around LTI. It starts with OAuth2 at its core. And so OAuth2 provides a number of different types of ways to authorize and authenticate. With LTI, we are using client credentials grants exclusively. On top of that, we're using OpenID to connect because we are connecting two web applications together via a browser or user agent in the middle. And when you have a user agent in the middle, there is the opportunity for things like cross-site request forgery that we have to mitigate for. In addition, OpenID Connect defines a standard payload to pass data from one server to another to identify the user and some other contextual information. So rather than reinvent that payload format, we adopted an industry standard OpenID Connect. On top of that, the IMS Global has built its security framework document to be used by all of its standards, including One Roster and QTI and you name it. And then on top of that, we have the LTI 1.3 core specification, which pulls all this together and clearly outlines exactly how the security around an LTI launch and services should behave. So at the core of LTI Advantage, we have the core, which is called LTI 1.3 core, and there's a specification out there for just that. And then there are 3 additional services. Now, deep linking is not necessarily a new service. It was available before LTI 1.3 in Advantage, but we reworked it to be more powerful and more rich. And of course, the data format has changed a lot as well. There was a membership service which got rebranded as names and roles, and now we've added a groups service, and that really just allows a tool to get the course roster and a list of ad hoc course groups for a particular course context. And last but certainly not least is the assignment and grade service, which is a much richer service for allowing a tool to get and set grades from and to the platform. And we'll look at all of these in a little more detail. The nice thing about this architecture is we can add other services in the future. We can add tool services so that LTI can ask the tool for information. The platform can ask the tool. We can add content services where the tool can ask the platform, what content have I already inserted in this course outline so that I can keep track and not display those choices again. So let's take a quick look at deep linking. You've got the LMS or VLE, what we are calling the platform in LTI speak, and it wants to get some content into that environment. And so it makes a deep linking request to the tool, which is just an LTI launch with a certain set of parameters. And the tool then presents a UI. So the assumption here is that this is a browser-based UI flow, just like LTI has always been. You launch to the tool, it's a UI web app. It displays a user interface for selecting content. Maybe it's an assignment. Maybe it's a video that you created with Panopto or Kaltura or Echo 360. Perhaps it's a chapter in a book from Cengage or Pearson or McGraw-Hill. And then the instructor, typically it would be the instructor, but it could be the student as well. There are certainly student use cases for this, would select the content and it gets sent back to the platform. And then assignment and grades is a similar thing where a platform launches to a tool. Maybe the tool has some sort of an assessment, a quiz, a video you're supposed to watch and get assessed on it. Maybe the tool is able to track attendance. The tool can then grade that work, that attendance, that assessment, whatever it may be, and send that grade back to the platform. And in the LTI world, the platform, the LMS, owns the gradebook. Now, at the end of the day, at the end of the term, the student information system, the SIS, owns the gradebook. But this is the gradebook for individual items, for individual content items, for individual attempts, et cetera, et cetera. And the platform owns that gradebook. But now we're giving the tool the option to get that information and update that information. All right, so we've learned everything we need to know about LTI. How do we replace our B2 with LTI? Well, you build a web application. And you build it in your programming language and your UI framework of choice. It is a standalone web application, and all it needs to do from an LTI perspective is be able to receive HTTP forum posts and gets. Then you take your application and you support the LTI launch, and that's all outlined in the spec, and we'll go through an example set of code. Then you take that web application and you've got to deploy it somewhere, as we talked about in the previous talk. So there's millions of hosting environments out there on the planet. You get to pick your favorite one or host it yourself. Ideally, you would get IMS Global certified for your application so that you feel comfortable and your clients feel comfortable that it can be deployed in any LMS. With Blackboard, we have built a central registration service, so you register it with Blackboard once and only once. You register your application with Blackboard once, and then Learn administrators can deploy it to all the Learn instances out there on the planet. And then once it's deployed, instructors and students can use it. This is a sample tool data model. I don't want to go into a lot of detail on this today. But the idea is that you're going to have a registration for your tool, your application, with a particular LMS. And it's going to, so your data model, you'll give it an ID, and you'll need to know the issuer and the client ID. And that comes from the OpenID Connect spec. And that uniquely identifies this particular registration, not to be confused with a deployment. And then there are some pieces of information you need to know. You need to know the platform's login authentication endpoint. You need to know the platform's Oauth2 service authentication endpoint for getting bearer tokens. You need to know the platform's JSON web key set endpoint to get its public key to validate the signature of the JWT. You may need to know the platform auth provider, and you certainly need to know the key set ID for your public keys that map to the private keys that you are going to send messages to send back to the platform. And then you would store your keys however you want to do that. And then each registration can theoretically have multiple deployments. Say you're at a large institution like UCLA or pick a European one. But they have different colleges or different schools, and each one has a different deployment of that tool for billing reasons, for keeping data segregated, whatever. And that's where you would create a separate deployment for potentially for each registration, or multiple deployments for a registration. All right, so now how does the flow work? The flow is everything in LTI is bootstrapped by what we call a launch. So somehow a href, a URL, a link gets inserted into the platform's user interface. And when that link is clicked on by a user, there are some steps that have to happen before the tool can get that data and process that data. And so we're going to look at each of these steps in code, but the first one is the OIDC login flow to protect against cross-site request forgery attacks. Remember that we have a user agent in the middle, and that user agent can, there are ways to get people to click on links that don't originate by that user doing the clicking. Once you have passed the OIDC login flow, you will get an ID token. It is the JWT, or the JSON web token, that contains all the context information about this LTI launch: the user, the course, the resource, information about the platform, any custom variables that have been sent along with this launch that are specific to that context. And then as a tool, you need to validate that JWT. You need to validate the signature so that it hasn't been spoofed by somebody else sending you a malicious LTI launch. And then you get the payload. It's just a big JSON object with all this information in it, and you can do whatever you like with it. Let's quickly look at the OpenID Connect third-party initiated login flow. So here the user agent is the browser. The platform is the LMS or VLE, like Learn in this case, and the tool is your application. And in the browser, there will be a link. And the user will click on that link, and that will initiate the login request, which then does a get or a post to the login URL for the tool. The tool then redirects back to the browser's OIDC authentication endpoint, which is pre-registered, but it passes some information along with it, which is a state and a nonce value. And the reason for that is that when the tool, or when the platform gets that redirect back, that authentication request back, it validates that it knows who that is. The client ID has to be passed in with this as well. It validates that request as, I know who that client is. I have a registered client that it looks at the redirect URL that's passed in from the tool and says, okay, I'm allowed to post to that URL because that was pre-registered as well. And then it builds this ID token, this JSON web token, and it posts it back to the tool. And it posts it along with the state field that the tool sent in the first place. So that way the tool knows that the browser, the user agent that initiated this request is the same user agent that is posting this JSON web token. Because with cross-site request forgery, you could have somebody who builds a JWT, or JSON web token, and then sends you a link over instant message or email and says, click on this, and you click on it because you know them and you think it's safe, and it actually launches their JWT with all of their information in it, as opposed to launching something from you. And that's what we're trying to protect against. Once the tool has validated that response, it parses the JWT, and then it displays its tool, its application in the browser. All right, let's look at some code. This isn't really too bad. The first, and this is all in node.js. This is all public, open source, available. We'll have URLs at the end of the presentation. The point is that I had to pick some programming language. I picked Node. We are building an example in Python. There's a lot of other examples out there in Python, in Ruby, in PHP. So you don't have to do it in Node, but I'm just keeping it to the very simple basics here. So I need to have a route in my application that takes an OpenID Connect login request. And so I just get the HTTP request and response object. I get my configuration. And I basically take all that data that I got passed in, and then I need to construct a redirect URI that the platform is going to post the data back to, and that has to be pre-registered with the platform. I have to pass back some of the data that the tool sent me, the login hint and the message hint. And then I have to create a state value. This is actually optional, but this is the one thing that protects you against cross-site request forgery attacks. And so that, in this case, is just a random UUID. And then I need to pass the redirect URI, and I need to pass application, or the client ID. Sorry, the client ID that, again, was pre-registered. Blackboard will give you a client ID for your registration. When you get the login request, you're going to have to look that client ID up and return that here. Now, the idea behind the cross-site request forgery attack is that you save off this state value, and the OpenID Connect spec says to store it as a cookie, and that's all you can do today, at least from a standards-based point of view, store it in a cookie. And we know that there are problems with third-party cookies and iframes, and so we can talk about that later. But right now, let's just assume that cookies work. And then you redirect back to the OpenID Connect auth URL that was pre-registered with you. So that's this section of code. It's really a quick, you get a login request, you send the same data back with a couple extra pieces of information as a redirect back to the platform. The platform then is going to launch to you the actual ID token, the actual LTI payload. And that's going to be with a form post. And that's been in the spec since 2010. It's always been a form post. This time, though, there's only really two form parameters. There's that state value that you sent back to the platform in the auth request. It's sending back to you. And why does it do that? It's so that you can look up the cookie value that you stored with the value that the platform sent you on the launch. And if they aren't the same, it means that the user agent, the browser that initiated the request, is not the same user agent that is continuing this request. Then you take the payload and you verify that token. And we'll look at how you then pull information out of that payload. And then we're going to look at the next step, which is not required, but it involves how you work with the Blackboard public REST API. But first, let's look at this verify token step, because I don't want to have any magic happens here steps. So there's a little bit of code here, but it's not too complicated. The ID token is in three parts separated by a period sign: the header, the body, the signature. So you get the header, you get the body, and then you have to pull the audience out. Unfortunately, the spec writers of OpenID Connect said that the audience field, which is the client ID, it could be an array or it could be a single string, which is a horrible thing to have to deal with in a programming language, especially a typed one. So that's why we have this code here. And so we get the client ID from the JWT, and then we have to validate the signature. How do we validate the signature? We have our JWKS URL that was pre-registered for the public key for Blackboard, and we call that URL to get the public key. We get the public key, and the KID, or the key ID, is from the key ID that was used for that public key set. There could be more than one public key in there. Is pulled out of the JWT payload, And then we call jwt.verify. Now this is a library. We didn't write this code, and you don't need to write this code. Nobody needs to write this code. This code's been written for you. So given an algorithm and given a JWT, you can verify that that JWT was signed by the person who said they signed it. If you trust, basically, if you trust this URL right here, which is the URL of the public key that you're accessing. So that's all it takes to verify a JWT. Now we're going to get into some proprietary stuff for using the Learn REST API, but it's good to do this all up front. So we're going to assume that you want to use this application is using the public REST API, and it is going to use the authorization code workflow, which means that the user has to grant, the end user has to grant permission to the tool to access the resources that for that user on the platform. And so the way we do that is, well, if you look back here, sorry. If you look here, we have our auth code URL. This is how we get a Learn authorization code. And we have to give it a redirect URI. And then we redirect to that URL. And that tells Learn, that goes back to Learn. And Learn says, oh, I'm going to get you an auth code. What Learn does behind, or not behind the scenes, in front of the scenes, is it prompts the user in a UI that says, hey, do you allow this tool to access your resources in Learn? And you can either deny or allow. Then Learn redirects back to you, and you get the state field back because we passed it in with the redirections. Now we get it back. And if we get a code, the code is on the URL. That's the query code right here. If we get that code, then what we can do is we can get a REST API OAuth2 bearer token. And that is done in this magic method here, which we'll look at next. So what do we do there? We have to build out our authorization string, okay, and that comes from this code. Well, so it comes from a couple things. One is, so we have registered, pre-registered an application key and a secret with the tool that you got from the developer portal in Learn in Blackboard, and you build your authorization. This is your bearer token authorization string from that key and that secret right here, key and secret. And then you post to Learn an authorization code type grant, and you have to pass in that sorry, I lost my train of thought here, but you need to pass in that auth code that you got back from the previous step, and then you post that to Learn, and the response will be your OAuth2 bearer token. Now this bearer token will have a lifespan of maybe 60 minutes. It allows you to now make REST API requests back to Learn to get data or update data into Learn. And so you will cache this token, and when the token expires, then you can get another token. And there's a concept of a refresh token that you can use to keep your token refreshed so that you're not having to go through all of this same round trip every time. All righty. It turns out if you want to make service calls back to the platform via the standards-based LTI services, you need to do virtually the same thing, except it's a slightly different security model. So you have to use a slightly different mechanism. So in this case, we're going to build another type of, we're going to build a JWT basically that is got a post and a URL, and we post that back to, and it's got a body. So it's got options and it's got this body. It's a client credentials grant. It's got to be this assertion type. The client assertion is this thing we made up here. It's just a JSON object, and we can look at that. And then the scope of what you want this token to be good for. Is it just reading the names and roles, or is it to be allowed to update grades? And then you do the same thing. You post to learn, it's going to give you a token back, you cache the token, and now you can use that token for LTI service calls. Perhaps someday we can align the security models between our public REST API and LTI so that one token will work for both environments, but right now they're separate tokens. All right, and now we've got all the data. We got the JWT. It's just a JSON object at this point, right? We verified it. We got our tokens to make service calls back to learn. And so now we're going to build a UI. So we're going to redirect back to, if we go back up here, we go back up here. Oops, sorry. If we go back up here, we got our learn REST token. We got our LTI token. We just looked at that code. And now we're going to redirect to our UI. And in our case, we're using the JWT payload target link URI to decide where to route this request. Our application may serve multiple functions, and we need to know how to route that request. So now, this is our UI code. This happens to be in React. You can build your UI however you want to. That redirect there, because React is really its own thing running in the browser, I redirected to a URL that can then load that React page. But you can implement your UI however you want to do it. You can do it in Flask, or you can do it in whatever framework is your favorite framework. And what happens is the way React works is it says once a component mounts, I can then make AJAX calls, REST calls, they're fundamentally, they're AJAX calls back to the server. So you've got this React application running inside the browser. It can make AJAX calls back to the server. And in this case, I need to get the JWT payload because that's got all the information about my user and my course. But it doesn't have enough information for me, it turns out, because LTI only specifies a certain amount of information that is standard across all LMSs. And so there might be some real specific information that you want about that user or that course or that resource or the grade book or whatever that you just can't get through LTI. And that's where REST comes in. So here I'm making the call back to my server. This is just a React pattern to get the data that was in that JWT. And then here I'm making a call that is going to end up being a REST call back to learn to get more information about the course. So this one is trivial because we've already stored the JWT in the server for that particular launch, and the launch is identified by this nonce here. This is slightly different, so we're going to look at that. So what this endpoint does is this is called from my React app. But now what it does is it takes that nonce and it gets the cached REST token that we just created in the earlier step. And then it figures out from the JWT that we've stored for this launch on the server what the learn server is, what the course ID that we're talking about. We will set the authorization header to be the bearer token that we just got and cached. And then we make a get call. This is a get call to this URL. And that URL is defined in our Swagger documents and the public REST API. And it says the URL to your learn server / learn API public v2 courses UUID course UUID. And that gives you all the information as a big JSON blob about that particular course. And then we take that data and we send it back to the React app. And now the React app says, oh, I've got this data back, right? I fetched it, I get the data back, and I want to store the date that the course was created because I'm going to display that in my IU. That's the one piece of information. But you could, of course, save the other information about the course. And you're done. That's it. That is how you took a B2 that displayed information about a user and a course inside Learn to a LTI and REST application. Also, ostensibly running inside Learn. In this case, it's running inside an iframe, or it could run inside a new tab. And it's got all the same information that it got from the LTI, and it's got the course created time that it got from the REST call. And the other thing that this particular tool, and again, this is open source, you have access to this, it shows all the information about the JWT. So you can get a feel for all the other types of information you can get from a JWT. Really quickly, we're not going to look at an example of this today, although we do have an open source example of it as well. The Ultra extension framework allows you to build an integration that communicates with Ultra so you know what is happening and can request actions based on that knowledge. The idea being here, if you want to know when a user clicks on something and takes some action based on that and pop up a modal dialog or pop up a little banner displaying something inside the Ultra UI, that's what the Ultra extension framework allows you to do. So for example, Eesysoft uses that by providing some online context sensitive help. So they pop up this little frame right here within the Ultra UI. Here's an example of Scott popping up a little frame with a video stream through AWS, through Twitch and AWS to display his presentation while he's presenting it. And so those are the kind of things you can do with the Ultra UI. You can customize the UI, you can embed your own components by using the Ultra extension framework. We don't have enough time to go over the details of that. Here's a really high level overview of how it works. You build an LTI application, you authorize, you use authorization code grant to get an Oauth2 bearer token. You render your JavaScript. You're basically, Ultra will create an iframe for you that you can render your JavaScript in. And then you can create a channel where you're using window.postMessage to communicate between your application, your JavaScript application, and the Ultra UI. And when you see a certain event that you're interested in, you can update your UI appropriately. All right, we're running out of time here. I'm going to wrap things up, but real quickly, to register an LTI application and a REST application, so you go to one place to register your application that we've talked about building at the beginning, you go to developer.blackboard.com, and we have a staging site if you want to test not in production, which is highly recommended. It's self-registering. You create an email account, you create an application, and you give it all this information: name, description, a domain or more, a group that you want it to be part of. And then if it does support LTI 1.3, you would give it those URLs that we've talked about: the initiation login URL, the redirect URL, and the JWKS URL, and a signing algorithm. Once you create that application, you are then given a bunch of information. Sorry, I skipped a step. You are given a bunch of information. You're given the application key and the secret, and we use those to get the Oauth2 bearer token for the public REST API. This application ID is also known as the client ID in LTI speak, and this is the ID that you will register in Learn. You're given an issuer, which is part of the OID Connect spec. You're given a public key set URL, which we talked about. You're given the auth token endpoint to get a Oauth2 bearer token for making LTI service calls, and you're given an OIDC auth request endpoint for completing that OpenID Connect login initiation flow. So we've looked at all these values. These are values you'll have to save inside your application in your database in a config file, however you store that information. Now, if we go back to this slide, with LTI, we have this concept of placements in Learn. It's where does your LTI tool surface in the UI? Is it a deep linking tool? Is it a course tool that's at the course books and tools level? Or is it something that's going to show up in the course outline as a content, as a resource content? Or is it going to show up in the system tools area or the admin area? And so you can register those placements here. You give them a name, a description, a type. We have 5 or 6 types. If it's UEF, that would be one of the types here. Course, content, deep linking, system, admin, and UEF are the types that you'll see here on this list. Oh, proctoring is a new type, but we only let Blackboard administrators set that up if you're a proctoring tool. You can decide whether to give students access to this tool. You can specify whether it needs to be launched in a new window. Some tools don't play nice in an iframe. And then you give it a target link URI, which really is just a route. It's just a parameter in the launch that says, where do you want this launch to direct to your tool? You can give it an icon that'll show up in the Learn UI, and then you can give it custom parameters. And these substitution variables are how you can get additional information about the launch, about the course, about the user, about the system that aren't part of standard LTI launch. All right, once you've done that, then you go to your Learn System Administrator, you go to the integrations area, and you have to register the LTI tool, and you have to register the REST tool. But those are just entering that application ID, and that's it, you're done. At that point, your tool is now, the Learn admin has to enable those tools, allow access to those tools, but once they have done that, your tool is now available within the Learn UI. So wrapping up, you need to read some of these specs. I highly, highly recommend you read these specs because LTI is built on industry standard technologies. It's built on OAuth2. It's built on OpenID Connect. It's built on JSON web tokens. And then of course, LTI is its own set of specs. And so Blackboard isn't going to reproduce all of those documents because they're already out there in the public domain. We do have some really good developer, I think they're good because I wrote them, but we have some developer documents on docs.blackboard.com to help you basically go through everything that I showed you here on how to configure your LTI tools and get them deployed, registered and deployed. And we have a list of resources. So this is our open source example of the application tool that I showed you. This is the Hello World B2 that we migrated from a B2 to this LTI and REST application. Scott Hurrey has built this UEF example in Python. So if you want to explore the Ultra Extension Framework, we have an example for that. This is our document developer docs for LTI REST, UEF, and everything else developer for Blackboard. This is the dev portal. And then these are some third-party, these are the IMS specs and some third-party libraries for doing LTI in other languages. Thanks for your attention, and I can take questions. I think even though it's about 4 in the morning my time, I should be there live in person, ready to help answer any questions, and we did this in 47 minutes. Thanks for attending, and we'll talk soon. Bye.
Thanks, Eric. Excellent presentation as always. We will continue to answer questions in the chat, but I want to turn it over to Nicholas since we're about 4 minutes over, just so we can keep the things going. Thanks, everybody.
Thank you very much, Scott. Thank you very much. So I guess we will start in a few minutes. I am Nicholas Albuzi. I am the regional manager at Blackboard, and we will be hosting a session about Dante Alighieri Society in 2 or 3 minutes.